It's always tough to be the afternoon speaker right after lunch. I got it. But hopefully you will see in my talk some of the things that we heard throughout the morning and how we are going to be responding in the S&T community to those challenges which have been put forth by our leadership, including Dr. O'Neill, including General Corelli, including General Vane, and all of our folks who are looking at how we adapt and transform and respond. And hopefully that you heard from my previous remarks this morning and then reiterated pieces of it that we need to be as agile and adaptable as our soldiers are on the battlefield. And that's what I'm going to be talking about, which is why the title of my talk is Reinventing Army S&T. Now that doesn't mean that Army S&T is bad. Okay? Don't anybody think that that's what I'm saying. Doesn't mean that we're doing anything wrong. Okay? What it says is we need to step back and take a look at ourselves in this environment and figure out what we should keep, how we should do business better, what we should throw out, and what in particular is the most important aspect of our job. And in order to do that, we have to look at that, and it will take some changes, right? Changes are what invention is about. Finding new ways and new things and discovering new things is what invention is about. And I would postulate here that very much while we are a community where we have people who do this for a living, as a collective, we probably have kind of gotten set in our ways. And we've probably gotten to the point where we haven't taken a good look at ourselves, and that's what I'm calling us all to do with the title, Reinventing Army S&T. Let's go to the next chart. All right, let me go to some definitions. I'm not going to read all these to you, but one of the things that happens here, and for those of you who don't know, I'm an old school teacher, okay? And old school teachers never die, they just find something else to teach. All right, and so one of the things that I go back to is before you start anything, make sure you're all talking the same language. Make sure that you understand the terminology. And whether you agree that these are the exact right definitions or not, these are terms that get thrown out all the time in our community. Science, invention, innovation, and engineering. Are they all the same? No. Do they get used interchangeably often? Yes. Are they related? Yes. But they are very different, and they're very different mindsets often. Okay? And so I ask you to think about this, and I ask you one of the things as you are looking at yourselves, looking at us as a community, looking at others in this community, let's try to be a little more careful, understanding that there are some distinctions between these things, and there's a balance that we have to strike among these things. Next chart. Some more definitions. Technology. This is one of my pet peeves, by the way. All of a sudden, everything becomes a technology. This is a technology, right? A process is a technology. The latest radio is a technology. Yeah, all of that stuff. But we get kind of sloppy because then the word science and the word technology become interchangeable in a lot of people's minds. I think we need to just think about it. Right? Technology is the application of science. Right? Technology is something that sometimes we get by practical application of knowledge or by a method of accomplishing a task. Demonstration. Okay? That's an important one. We talk about demonstration all the way, and I don't mean protests, all right? We've all had some experience with protests, unfortunately, particularly in the military community. But demonstration has a place. The one I didn't put up here that I should have, but General Vane probably and I would have had an argument about it because we love to argue about it. We really do love to argue about it, is experimentation. Did you know that there is somebody in the Pentagon who owns experimentation? Okay? And that some of us aren't supposed to talk about experimentation? And I'm going, whoa, wait a minute. We're scientists and engineers. That's part of what we do. But experimentation is different than demonstration. So let's just think about that a second. Keep these things a little bit for your own thought. And then there is transition. Oh, and is this one we get in real trouble with? Because what's transition from a scientist doing 6-1 research to a 6-2 or 6-3 program, from a 6-3 program to a PM or PEO, from a PM or PEO or somebody who's developed something new, somebody from industry, they're all different. We use the same word, transition, to mean many, many, many different things. And it's all okay as long as we just recognize and make sure that we are communicating with one another. Because often when we use these words, we think somebody else is hearing it in the same way we mean it, and sometimes that is not the case. Therefore, communication doesn't happen. Next chart. And another set of definitions. First, let's talk about resources. Resources come in multiple flavors. Resources are funding. And in our world, there's the 6-1, 6-2, 6-3, and yes, 6-7, which have these definitions: basic research, applied research, advanced technology development, manufacturing technology, which are really lanes, but we often confuse the money with the activity. 6-1 is a flavor or a type of money. By statute, it has things for which it can be used and for which it's not supposed to be used, right? And so we, as a community, pretty much understand that. Now, I'll tell you, some of our partners don't understand that. Sometimes our people from industry, certainly our people from academia, so different people don't understand it. Certainly our allies don't understand that, okay? But the fact of the matter is we talk in these as if they're something real, right? 6-1, it's a kind of money. All right, but it talks about being a basic research. It talks 6-2 being applied research. And particularly when we are doing things, and what comes out of my office, particularly when we're writing what we call R forms, which are our way of communicating with the Congress, all right, these things we become very, very sensitive to words and make sure that our words and the kind of research we're doing as we're describing these types of money fit with what statutorily we have to do. Now, one of the problems that happens is that in an economy as we have today, as General Vane was talking to us about, where we are seeing drawdowns, we will see more drawdowns, then what's going to happen? All right? Then other kinds of money, which are in other kinds of activities, all right, beyond what we do, are going to go down. When they go down, people are going to want and need more money, which is then going to put a strain on our funding, and people are going to want to take some of the funding away. Unless, of course, we can make good arguments, solid arguments, non-emotional arguments about the value of the funds that we use. But resources are not just about funding. Resources are also about people. And you've heard in almost every talk today about the importance of people. People who in each one of these kinds of areas, and these are just examples, but people who are trained to do 6-1 research, basic research, invention, discovery, okay, they're typically people who have education, degrees, skills, capabilities associated with basic science, basic engineering skills, basic academia coursework. And yet, over here, when you do applied, you still need, you notice there's the same kinds of people. There's a slight change, though, because sometimes, right, people who invent and discover are not necessarily the same people who are good at applying, right? But some are. So you can't categorize anybody. What we need to do is recognize that there are skills that are theoretical and experimental skills. There are skills that are scientists, technologists, and experimentalists who understand how to make experiments, who understand how to get data, who understand how to interpret data. That's what we're talking about here. And yeah, the disciplines may cross each other, right? Sometimes people can do both of these realms. Sometimes they can't. I was lucky in my career to be able to work all the way from 6-1 through 6-2 to 6-3 and on into manufacturing to get to do it all. All right? That was really cool. Those of you who have had that experience know that that's really cool to be able to take a piece of your research, something that came from your brain, and carry it all the way through. Not everybody can do that, but that's what we as leaders have to do. We have to help people to do that. We have to help keep these people, okay, educated, to keep them interested, to keep them motivated, to keep them having the skills and applying those skills in our community, regardless of where you live. And when I say where you live, what organization you're in. Regardless of whether you're in academia or a laboratory or a center or the medical community or whether you wear a uniform, okay, or whether you're in industry or whether you're in somebody else's lab, okay, in a foreign country or wherever. Wherever you are, okay, you have a responsibility to bring on new folks and to refresh your knowledge and your capability as well. And then resources include partnerships. Now these numbers right down here at the bottom of my slides give you an indication about what the percentage of our 6-1, 6-2, 6-3 investments go to industry versus what in academia versus what we keep in-house. Right? These are rough numbers, but they're pretty steady most of the time. And so partnerships is how we do this. And this is what I consider our resources. People, dollars, and the partnerships that we have both organizationally and with the people themselves.